Hey guys, so this is our class for Wednesday, March the 3rd and also Thursday, March the 4th. So tonight we're going to be graphing quadratics. So when you have a quadratic equation, so let's say this is let me draw two different graphs. So if you have a positive quadratic equation like this, your parabola, so when you graph a quadratic equation, it always makes the same picture. You're going to either have a positive parabola that goes up and up like a smiley face, or if the first coefficient or the coefficient of A is negative, you are going to have a picture that looks like this. So it's like a sad face. A sad parabola is what I call it. Okay, I know that's not an official term. So a lot of times when you have a parabola, you'll have two x-intercepts. So remember what x-intercepts are. It's where your graph crosses your x-axis. So a lot of times you'll have two. Sometimes you won't have any. So for example, if your parabola was down here and looked like this, it would never cross the x-axis. So you would have 0 x-intercepts. And then sometimes you might have a picture that looks like this and it crosses once. Okay, so those are your choices. For x-intercepts, you either have 2, 1, or 0. So that's what we're going to look at. We're going to look at finding. Oh, and also I wanted to mention, if you have a happy parabola, if you have a positive parabola, that means that you have a minimum point. You have a point on your graph that's the lowest point before it starts going back up. If you have a negative parabola, on the left side is going to be increasing, and then you'll have a maximum value before it starts decreasing. Okay, so if you have a negative parabola, that means you'll have a maximum point. If you have a positive parabola, you're going to have a minimum point, a lowest point. All right, so let's look at some examples. So first of all, the quadratic equation is listed there for you. X is always equal to the opposite of b, or negative b, plus and minus the square root of b squared minus 4ac all over 2a. Then we're going to look at our vertex. So what's either the maximum or the minimum? Those are called the vertex. And we're going to look at our x-intercepts. And then finally, to graph it, we need two other points besides the vertex and the x-intercepts. It's always recommended that you pick two numbers on the left and right side of the vertex. All right, so whatever's under the radical, that's called the discriminant. It's going to tell you how many x-intercepts you have, okay? So we'll talk about that as we go along. So the first thing I'm going to do, I'm going to stop sharing that screen, and I'm going to pull up a website. I'm going to pull up desmos.com. All right, so let's pull up Desmos right here. Nope, that's in my way. So hopefully you guys can see that. I hope it's showing the right screen. All right, so let's say I'm going to type in x squared, and then I'm going to put plus 6x plus 5. Now, we're going to graph it by finding all of these different points, but I do want you to know that if you pull up Desmos, DESMOS.com, and all you have to do is type in your equation, it will graph these for you. All right, so I encourage all of you, and your teachers are allowing you to do it. So it's not like we're cheating, because your teachers are allowing you to use Desmos, but that's an awesome website. It will graph these equations for you, so you should use your resources, right? And we'll talk about that a little bit more during our class nights. All right, so the first thing we're going to do is graph this equation right here. So the way to do that is we're going to find the vertex, then we're going to find the x-intercepts, and then we're going to find two other points. Okay, so to find the vertex, you're going to use the equation negative b over 2a. So x is equal to negative b over 2a. Well, just like when we used our quadratic equation the other night, a is always attached to the number that's multiplied by our variable squared. So our coefficient of x squared is 1. So a is 1, b is 6, and c is 5. So to find the vertex, we're going to use this formula right here. So we want to write the opposite of 6, which is negative 6, divided by 2 times a, which is 1. That means negative 6 divided by 2 is negative 3. And then we need our y value. Well, to get the y value, we're going to plug in negative 3 into this equation. So x squared, so that means negative 3 squared plus 6 times negative 3 plus 5. So negative 3 squared is 9 minus 18 plus 5. That would be negative 9 plus 5, which is negative 4. That is our vertex. Our vertex is the same as our minimum. How do I know this has a minimum? Because our coefficient is positive. So we're going to end up with a happy parabola, a positive parabola. So the lowest point or the minimum point is this, negative 3, negative 4. 1, 2, 3, negative 1, 2, 3, 4, right there. That's our lowest point. All right, now we want to find 2 points. Now we want to find our x-intercepts. So remember back when we talked about x-intercepts, the x-intercepts is what x values are when y equals 0. So that means we're going to take our equation, we're going to set it equal to 0, and we're going to find out what our x-intercepts are. All right, let me pull my pen up. So we have x squared plus 6x plus 5. We're going to set it equal to 0. Y is 0, so we want to find out what our x values are. So we want to think of 2 numbers that multiply give me 5 and add to give me 6. Well, that means those 2 numbers are 5 and 1. Because positive 5 times positive 1 is 5, but 5 plus 1 is 6. So now we're going to take both of those parentheses, set them equal to 0. And then when we solve for x, we're going to say that x is equal to negative 5 and x is equal to negative 1. So our x-intercepts when y equals 0, our x-intercepts are negative 5, 0 and negative 1, 0. So let's graph that. Negative 5, 0 is there and negative 1, 0 is here. And now the last thing I'm going to do is find 2 points besides my vertex and my x-intercepts. So I'm going to get rid of all this. Erase everything really good. If I leave any points on the board, I know it drives OCD people crazy. So I try not to leave any points on the board. All right, so we know that when x is negative 5, y is 0. We know when x is negative 1, 2, 3, y is negative 4. And we know when x is negative 1, y is 0. So we want to probably use these 2 points that come between there. Well, that means that we want to know what y is when x is negative 4 and when x is negative 2. So we just found the 2 numbers that are right between the numbers that we already have. So we're going to plug in negative 4 for x. So we're going to do negative 4 squared plus 6 times negative 4 plus 5. Negative 4 squared is 16 minus 24 plus 5. So that would be negative 8 plus 5 and y equals negative 3. And probably, since this is very symmetrical, when we plug in negative 2 for x, we're going to get the same y value. So if x is negative 2, we're going to do negative 2 squared plus 6 times negative 2 plus 5. So negative 2 squared is 4 minus 12 plus 5. 4 minus 12 is negative 8, and negative 8 plus 5 is negative 3. So we're going to graph -4, -1, 2, 3, and then -2, -1, 2, 3. And there's all of our points to let us graph our parabola. But like I said earlier, if I just type this into Desmos, I get all of those points automatically. Okay, so use that website. It's a great website. It'll help you graph these, and it'll help you on your test even. Okay. All right, so let's try another one. Now this time, if you notice, our equation, the first, or letter A, is -1. That means we're going to have a parabola that looks like this. Okay, so the very first thing we're going to do is find the vertex. Since we have a negative parabola, that means we have a maximum. We have a maximum number, and then our parabola goes on down in both directions forever. So we're going to use -b/2a. We always use that to find the vertex and also to find the maximum and minimum x values. And then to get the y values, we plug in this value for x. So let's start with b is 8. So we want the opposite of 8 over 2 times a, and 2 times -1 is -2. So -8 divided by -2 is +4. So that's our x value. So to get our y value, we're going to plug in 4 for x. So minus 4 squared plus 8 times 4 minus 15. So the opposite of 4 squared is -16 plus 32 minus 15. Well, -16 plus 32 is 16, and 16 minus 15 is 1. So this is our vertex. We're going to go right 4, 1, 2, 3, 4, up 1. Well, if you notice, oh, we know it's going to be a negative parabola. I was about to say if it's a positive parabola, then that means we won't have any x-intercepts. But it is a negative parabola, so it will have 2 x-intercepts. All right, so that's the next thing on our agenda, to find our x-intercepts. So let me get rid of all this stuff. So to find the x-intercepts, you have to set y equal to 0. So that's what we're about to do. We're going to say -x squared plus 8x minus 15 is equal to 0. So the first thing we're going to do is factor out that -1. We want our a to be a positive number. So we're going to factor out -1, which makes this +x squared minus 8x plus 15. So now we want two numbers that multiply to give me +15 and add to give me -8. So if I write down the factors of 15, I know that 5 and 3. So -5 times -3 is +15, and -5 plus -3 is -8. So I'm going to set both of these equations equal to 0. So if I add 5, I get x equals 5 and x equals +3. So when y equals 0, that means our x-intercepts are 5, 0, and 1, 2, 3, 0. Now it does want two numbers other than the vertex. So the vertex, let me write these down. The vertex is 1, 2, 3, 4, 1. I'm going to put that in the middle. My y-intercepts are 3, 0, and 5, 0. So because there's not a whole number that comes between them, I'm going to go ahead and use 2 and 6. Do you see that? So since this is very symmetrical, those two y values should be the same. All right, so let's find out what y is when x is 2 and when x is 6. Let me get rid of all this stuff. I don't want to erase everything, but I do want to erase all of that. All right, what about when x is 2? So we're going to say the opposite of 2 squared plus 8 times 2 minus 15. Well, the opposite of 2 squared is -4 plus 16 minus 15. And that would be what? 12 minus 15, which is -3. And I bet you when x is 6, y is also -3. So we're going to do the opposite of 6 squared plus 8 times 6, whoops, minus 15. Well, that would be -36 plus 48 minus 15. And let me just use my calculator. -36 plus 48 minus 15 is -3. Exactly what I thought. So when x is 2, y is -3. 1, 2, 3. And when x is 6, y is -3. And so those are our 2 points other than the vertex and the x-intercepts. All right? But I encourage you to use Desmos. All right, we're going to find the vertex. So to get started, we're going to do -b over 2a. So a is 1, b is 7, and c is 10. We do know that this is a happy parabola because a is a positive number. So we're going to use the opposite of b, so the opposite of 7 over 2 times 1, which -7 divided by 2 is -3.5. So let's plug in -3.5 to figure out what y is. Well, we're going to say -3.5 squared plus 7 times -3.5 plus 10. So you know what? I'm just going to use my calculator. I'm going to plug all that in. I'm going to say parentheses 3.5 squared plus 7 times -3.5 plus 10, and all that equals -2.25. So -3.5 and -2 1/4 is our vertex. So we're going to go left 1, 2, 3.5, down 1, 2 1/4, about right there. Okay, so that is our vertex. Now we need our x-intercept. So we want two numbers. When we multiply, we get 10, and when we add, we get 7. Well, that would be +5 and +2, right? So then if we set them both equal to 0, we would say, whoops, that when y is 0, x is -5 and -2. So we're going to say -5, 0, and -2, 0. So those are our x-intercepts. All right, so let me get rid of all this stuff. All right, go away, go away. All right, so let's use the points that we already know because we have to come up with 2 other points. So let's do our XY table. We know our vertex is -3.5, -2 1/4. We know that when x is -5, y is 0, and when x is -2, y is 0. So what would come between that? Well, we know that this, we'll just go ahead and use whole numbers. Let's do -4 and -3, right? All right, so when x is -3, so we're going to do -3 squared plus 7 times -3 plus 10. So -3 squared is 9 minus 21 plus 10. I'm going to put that in my calculator. 9 minus 21 plus 10 is -2. And then I'm going to use, what if x is -4? So -4 squared plus 7 times -4 plus 10. So that would be 16 minus 28 plus 10, and we get -2. So those are our two other points besides our x-intercepts and our vertex. So when x is -1, 2, 3, y is -2, and then -4, -2, and oh, I wish I could draw. Wish I could draw better, you guys. But anyway, that's pretty close. So like I said, Desmos will do that for you. And that's the way you do it by hand. All right, let's try another one. How many more do we have? All right, this is the last one of this section. So let's try it again. We have the vertex. So to find the vertex, we always do -b over 2a. So a is 1, b is -4, c is 7. So the opposite of b would be +4 over 2 times 1, which is 2. So 4 divided by 2 is 2. So that's our x value. And to find what y is, we're going to plug in 4x, 2 for x. So 4 minus 8 plus 7 would be -3 plus 7, which is +4. All right, so we're going to go right to 1, 2, and up. 1, 2, 3, 4. Now, what do you notice? This is a positive parabola. It's going to go up like this. Well, this is our lowest point. That means that our parabola will not have x-intercepts. So let's see what we get when we try to think of two numbers that add to give me 7 and, excuse me, multiply to give me 7 and add to give me -4. Well, I can't think of two numbers that multiply to give me +7 and add to get me -4. So let's use the quadratic equation. So since we can't do this by hand, we're going to use a quadratic equation, the opposite of b, plus and minus the square root of b squared minus 4ac all over 2a. So what happens is if you get under that radical, if you get a negative number, that means there are no x-intercepts. So I bet that's what we get. So the opposite of -4 is +4, plus and minus. -4 squared is 16 minus 4 times 1 times 7. So all over 2a. So let's just put what's under the radical in our calculators. 16 minus 4 times 1 times 7. And my calculator tells me it's -12. So when you get a negative under the radical, that means, whoops, it's a negative. That means there are no real solutions, which means that this parabola does not have x-intercepts. It doesn't. So when it says what are the x-intercepts, we're going to say that there are no real solutions. And we know that because it's a positive parabola, it's going to go up, and our lowest point is 2, 4. Okay, so that means we need two other points besides the vertex, and we don't have any x-intercepts. So let's try to find two other points. So let me get rid of all this stuff real quick. We know there's no x-intercepts, but we need two other points. Sorry, I gotta just erase this a little bit at a time. Okay, now we need two other points. We know the one thing we do know is that when x is 2, y is 4. So let's see what happens when x is, we can either do 1 and 3, or we can do 0 and 4. Let's do 0 and 4. We don't want to be right beside the 2. Let's do a little bit further away. Since it's very symmetrical, those two values should be the same. All right, when x is 0, we're going to do 0 squared minus 4 times 0 plus 7. Well, 0 minus 0 plus 7 is 7. And when x is 4, 4 squared minus 4 times 4 plus 7. 4 squared is 16 minus 16 plus 7. 16 minus 16 is 0. And 0 plus 7 is 7. So we have 0, 7, and 4, 7. Those are our other 2 points, and that's what our parabola looks like. And there it is. And we can see that this does not have any x-intercepts. It never crosses the x-axis. All right, let's move on, you guys. So now we're going to do 4.2b, and this is minimums and maximums. Like I said, when you have a happy parabola, a positive parabola, you're going to have a minimum, right? And when you have a negative or a sad parabola, you're going to have a maximum, and this is a minimum. You have a lowest point if it's positive, and you have a highest point, a maximum, if it's negative. All right, so it says the maximum and minimum of a quadratic function are the highest and lowest point on the graph. Each function has either a highest or lowest point based on its vertex. The y-coordinate is that point. So example 1, determine if the parabola points upward or downward and if it has a maximum or minimum. If it has a minimum or maximum, find out what that value is. So since A is positive, that means it's a positive or a happy parabola, which means it has a minimum. So the first choice on Hawk's Learning I'm going to choose is the word minimum because A is positive. Minimum. Oh, I don't know what I'm doing. Wow, that's all messed up, isn't it? Minimum. It has a minimum since it's positive. And now we want to think of two numbers that when we multiply, oh, excuse me, I don't need to do that. All right, so once we figure out if it's minimum or maximum, then we're going to use the formula negative b over 2a. Okay, so let me write that. Negative b over 2a gives us the x value. Now my pen's all messed up. I wonder if I can click it and make it better. I don't know. Negative b over 2a. That's our x value. And then to get the y value, we plug this value in. So our b is 5. So the opposite of 5 is negative 5 over 2 times a, and a is 1. So negative 5 over 2 is negative 2.5. So our x value is negative 2.5. Now to get the y value, we plug in negative 2.5 for x to figure out what y is. All right, so let's do that next. We're going to plug in negative 2.5 squared plus 5 times negative 2.5 plus 4. And guess what? I'm going to plug all that right into my calculator. I'm going to do parentheses, negative 2.5, parentheses squared, plus 5 times negative 2.5, and then plus 4, and I get negative 2.25. So we know there's a minimum, and that minimum is this coordinate right there. Okay, that is our value. You use negative b over 2a, then whatever you get, you plug in that value to figure out the y value. All right, so first of all, we want to know, are we going to have a minimum or a maximum? Well, our a is a negative number. That means we're going to have a sad parabola, which means we're going to have a maximum. So that's the first button we're going to click in Hawk's. And now to find the maximum, we're going to figure out what negative b over 2a is. We're going to plug that value in and get our y value. So negative b over 2a, our b is 3, so the opposite of 3 is negative 3 over 2 times negative 1. So negative 3 over negative 2 is positive. Negative divided by negative is a positive 3 over 2. So x is 3 over 2. And now to get our y value, we're going to plug this in for x. So we're going to say the opposite of 3 over 2 squared plus 3 times 3 over 2 minus 2. We can just plug all that right in our calculator. Negative and then parentheses 3 over 2 squared plus 3 times 3 over 2 parentheses minus 2 equals 1/4. 1 over 4. So we have a maximum, and this is our maximum value. All right, let's try another one. All right, here we have, is this a positive parabola or a negative? It's a positive, right? Which means we have a minimum. So we're going to pick the button that says minimum, and then we're going to use negative b over 2a to figure out what y is, and then we're going to, x is, and then we're going to plug it in to figure out what y is. So the opposite of 7 is negative 7 over 2 times a, which is 2. So we have negative 7/4. That's our x value. So then we're going to plug in negative 7/4 squared plus 7 times negative 7/4 minus 15. That definitely looks like a calculator problem. Negative 7 over 4 in parentheses squared plus 7 parentheses negative 7 over 4 parentheses minus 15, and I got, wow, that's a crazy number. But y, so when x is negative 7/4, y is negative 169 over 8. But that's the answer, that's the minimum, okay? All right, so let's look at this last question. You will have a couple of word problems, and this is one of them. It says the total cost of producing a type of boat is given by, and it tells us our cost formula, where X is the number of boats produced. How many boats should be produced to incur minimum cost? So whether it says minimum cost or maximum cost, you're always going to use this formula. Okay, so don't forget, these are not in the right order. This 16,000 is actually C. Negative 80 times x to the first power is actually B. And A is actually 0.1 times x squared. So we're going to use the opposite of B. Well, B is negative 80. So the opposite of B is positive 80 over 2 times 0.1. So when we plug that into our calculator, we're going to do 80 divided by 2 times 1.0, and we get 400. So that's the answer, you guys. How many boats should be produced to incur minimum cost? The answer is 400. So then if we actually take that answer and plug it into this equation, we should get the cost is equal to 0, right? Which is what we're after, but the first part of the question says, what is the minimum number of boats that should be produced? The answer is 400. So once you do this part right here, you're done with this problem. So you'll have problems like that. All right, I know that was a lot, you guys, but I encourage you to use Desmos. Definitely use your resources. That's a great one. And make sure you join me for class, and we will talk a little bit more about all of that. All right, you guys have a great night. I will see you on either Wednesday or Thursday.